All right, welcome back to lesson 8.6. Remember, we are talking about law of sines and law of cosines. Law of sines and cosines can be used when we are not dealing with right triangles. So part 1 was talking about law of sines, and then part 2 is going to be talking about law of cosines. So as you are getting ready to start this video, make sure you have your calculator ready. And I always remind my students to make sure you are in degrees. All of my answers will be in degrees. So just make sure you go to that mode setting and make sure that is correct. So we're going to start out with law of cosines today. This is part 2. And just a couple things. This equation is a lot of plugging in. I'll talk a lot about when we're doing some problems. Just make sure you are taking your time plugging it into your calculator. Another thing, if you ever have numbers within your problem that have multiple decimals places, go ahead and round within your problem to 4 decimal places and wait till the very end to round to the 10th. So those are just a couple things that I would remind you of or tell you before we get started. So law of cosines, so if I have a triangle, and again, the lowercase letters A, B, and C representing the lengths of the sides, and then opposite of those sides are the angles with uppercase A, B, and C. So if that is the case, again, all 3 of these formulas are actually the same. It just depends on what angle you're talking about. So notice that A squared equals b squared plus c squared. You should kind of see a resemblance of the Pythagorean theorem. Minus 2 times b times c times the cosine of a. So what I would just tell you is the first letter is going to be a side, and then opposite of that letter is the same angle. So a squared goes on the front, and then angle A goes on the back. And then the other 2 letters are just going to be b squared plus c squared, and then you're going to repeat b and c within that problem. So those are some things that help me remember this equation and kind of how to put it into place. So again, there's lots of numbers, lots of room for error if you aren't taking your time. So let's jump right in and start one, see what we can do. So we're going to find x, and we're going to round to the nearest tenth. So if you notice, we have more sides than we do angles right now. So that is how you can think about, I probably need to use law of cosine. So angle and side need to go on the front end and the back end. So I would say x squared equals my other 2 sides squared, 11 squared plus 25 squared, minus 2, and then I'm just going to repeat those numbers, 11 times 25 times the cosine of that opposite. So if I'm looking at x is here, my angle x is going to be here, so 45 degrees. Remember, cosine of 45 degrees is actually a number. So again, remember, if you notice all of those numbers in there, so you can put that in your calculator. Just make sure you're closing your parentheses, doing all the order of operation. So I like to do just a few steps first. So 11 squared plus 25 squared is actually 746. Minus, and then I like to do this portion in my calculator. So that is going to come to 388.9087. Notice I go to the 4 decimal places here, and that's going to equal x squared. So continuing that, x squared equals 357 point, I'm going to go to 4 decimal places. And then the last thing, to get x by itself, I'm going to square root that. So my x side is about 18.9 units. Okay, so again, not terribly hard to plug in those numbers, but you got to take your time when you're solving. So go ahead and stop this video, check your progress. Here is the formula and my plugins, and then as I go through my steps, I get answer of 22.7. All right, what if I have all three sides, SSS, and I need to find the measure of angle L? So a few things just to notice. The measure of angle L, so here, so this side that's across from it is going to go first, of course. 24 squared equals, okay, first thing. And then if I'm ever having to find the measure of an angle, remember I need to push that second button at the very end to get my inverse cosine to find my angle. All right, so 24 squared, because it's across from the angle that I'm trying to solve for, that equals 5 squared plus 27 squared, my other two sides, minus 2. Repeat those two numbers, 5 times 27. And then I'm going to put times the cosine of L. And in my first video, remember we took that out and we put x there. Sometimes if you put the cosine of L, it gets a little confusing for some people. So if you just put like a normal variable there, that may help. But remember at the very end, x has to be the inverse cosine of something. All right, so a few little bitty steps as we work through this. 24 squared is 576 equals 5 squared plus 27 squared gives me 754 minus 2 times 5 times 27 times x, so 270x. And remember, x is really the cosine of L. All right, solving order of operations, just like normal. Subtract that 754. You are going to get a negative, but notice here's a negative I'm going to have to divide by, so that negative will kind of cancel out. So I get negative 178 equals, bring this down, negative 270x. Divide by negative 270. So, continuing that, x is going to equal, and then I can literally just keep this in a fraction. And then I'm going to plug that into my inverse cosine. So, inverse cosine, I'm solving for that angle because x equals, I got it where I needed to. All right, so just as a reminder, when you get in that calculator, here we go. So inverse cosine of 178 divided by 270. You can reduce that fraction before you put in your calculator, or you can just let your calculator do the work. So I get 48.75. X equals 48.75, which rounds to, I'm rounded to the nearest degree, so the measure of angle L is going to equal 49 degrees. All right, again, that can get a little tricky if you don't take your time. So go ahead and try another one. Look at my setup. There's my setup if that confuses you. On this one, I kept cosine of P, notice, so you can see it that way as well, worked that way. And working all the way through angle P to the nearest degree would be D. All right, let's try some real world problems, just a couple. We'll try one, and then we'll do a solve the triangle problem. So from the diagram of the plane shown, determine the approximate width of each wing. So I need to find KJ, round to the nearest tenth. All right, so I know that these two sides are congruent, which also means angle K and angle J are congruent too. So I could put 20 over here, and this will be called X. So there's a few different ways you could solve it. To me, I'm going to do law of sine, because I can do 180 minus 50. Divide that by 2 because I have an isosceles triangle. So each of those base angles would be 65 degrees. Now I'm going to use law of sine because I notice that I have the angle, and then it goes to a side, and then another angle, and it goes to another side. So I have 2 angles and a side. The more angles, you probably could lean toward law of sine. More sides, you can lean to the law of cosine. All right, so remember law of sine from the first part, sine of my angle over the side that is across from equals the sine of my other angle over the side that is across from. All right, cross multiply that. I get x times the sine of 65 equals 20 times the sine of 50. Getting x by itself, I'm going to divide by the sine of 65. So just as a reminder, putting that in your calculator, I do two different steps. I do 20 times the sine of 50. I always push enter, and then I divide it by the sine of 65. Just so my order of operations don't get a little mixed up. All right, so my width of my wingspan is 16.9 meters. All right, we're going to skip that check your progress. We're going to go all the way down here. Ooh, maybe. There we go. To our solve the triangle. Remember, solving the triangle means you need all 3 sides and all 3 angles. And there's different ways to, go about solving these. I'm going to go about solving it my way, and you may have a different way that you want to solve it too, but you do need to use law of sine and law of cosine because remember, we don't have a right angle. All right, so first, personally, I'm going to solve for the measure of angle R because I have all 3 sides. So I need to use probably cosine because I don't have anything to set up with law of sine. So if I'm going to solve for R, I know that 9 squared needs to go on the front side equals 7 squared plus 8 squared minus 2. Repeat those numbers, 7 times 8 times the cosine of R, or I can make that x, that's fine. All right, so I get 81 equals 113 minus 112x, or the cosine of R. Subtract that from both sides. Negative 32 equals negative 112 cosine of R. Divide by 112. So x equals the inverse cosine of, and then I'm going to put that in there, 32 divided by 112. So the measure of angle R equals, I'm going to put that in my calculator, inverse cosine, and I'm to the nearest degree, so this is 73.4 degrees. So I'm going to go over here, the measure of angle R equals 73 degrees. All right, so I have one angle. So there's a few different ways you could do it. You could then go to the law of sine if you wanted to, or you can just continue with the law of cosine. And I'll just continue with that. I'll solve for the angle P. I'm going to set this up, and then you can finish solving it. I'm about to run out of time. So 8 squared, since I'm going to find the angle P. My 2 other numbers or sides times 2 times repeat those 2 numbers times the cosine of P. Alright, when I get all the way down here, I get negative 66 equals negative 126 times the cosine of P. So in my calculator, I'm going to put 66 per 126 So the measure of angle P equals 58.4.